Okay. And with this part again, this number 2. So the very first thing we got with this one is talks about linear relations. And again, we're talking about doing stuff in a straight line, which is again, we're talking about slope and all the other things that we're doing. X-intercepts, Y-intercepts, still kind of ties in with that a little bit. But linear equations, the standard form of it is ax plus by equals c. Okay, so it says a is greater than 1. So basically it's saying a has to be positive. We don't want a to be negative for what it set up. B, C can be to be positive or negative, doesn't really matter, but they try to keep it so that your A value is going to be positive. Now, some books don't worry about that too much. Sometimes you'll see some stuff in Math Excel where maybe the A value is negative. It's not a huge deal. It's just some people like for that A value to be positive. Some people don't really care too much about it. So, um, okay. Now, again, that's not the graphing form of it. We'll talk about that here in just a little bit as we get through some other stuff. But all right, so for this one, just to make sure everybody's okay with it. And again, this is kind of more solving equation stuff. That if you've got this equation and they ask you to put it where, again, the first term is positive, all we're going to do with this first equation to rewrite it is we're going to take everything here and multiply it by negative 1. Okay, so if you write it in ax plus by equals c with the a term being 1 or positive, then we just need to take everything and multiply it through by negative 1. All right, number 2. And again, all we're doing in this case is we're getting the x's and the y's basically all on the same side. So with number 2, we've got this 2x over here. We need to take it and take it from the right side and move it over to the left side. All right. And again, sometimes in Math Excel, you can leave it like that and it's okay. But, if we're going to get technical about it, in that case, they want that first term to be positive. So then we'll take everything here and then multiply it by negative 1. So we've got 2x minus y equals 9. All right. Number 3, pretty much there. The only thing you got to do on 3, of course, would just be to add the 24 to both sides. All right. With 4, add the 7x to both sides. So we've now got the x's over here. So that's 7x plus 7y equals 7. Oh, now, and here's one thing that they may not necessarily make you do it in this case, but it's kind of good to kind of think about it as we're going forward with some stuff. You've got 7x plus 7y equals 7. They've all got 7s in there, right? So a lot of times in this case, this is where if you've got something like this, they're going to say, well, if they've all got some common factor here, let's just divide them all by 7 so that we could just make it x plus y equals 1. Which, if we're going to graph it, that's going to be a little bit easier to graph than if we've got this, because if we go ahead and get ready for what we're doing, slope intercept form in a little bit, we're going to basically have that thing anyway. So, question? Yes. All right, and you could have even done that back here on number 3, that you've got 9, 6, and 24. You could have taken all of those numbers and divided them all by 3 and made it 3x plus 2y equals 8. Okay. I always like to show this one first because everybody's like, oh, yeah, they all got 7s. Let's divide it by 7. So a lot of times here in this case, again, if you see something that you've got a multiple of these, so you got 9, 6, 24, if you want to divide them all by 3, that would make it just a little bit smaller. And again, most time if you can simplify the numbers a little bit, when you start graphing and solving, a lot of times that's going to make the work a little bit easier. And that's basically kind of what they're looking at for this thing. All right, number 5. Here's where the fun kicks in. We've got fractions, right? And everybody loves fractions. But in this case, we're going to get rid of them. So and again, this is something hopefully going back into your Algebra 1 classes, that if we're working through some things. anytime you've got an equation, you've got fractions, you can almost always get rid of those fractions to make your life a little bit easier. So now, obviously, we can multiply by 4 here to cancel this one, but if we put a 4 over here, it doesn't cancel. So all we're going to do in this case is we're going to find the least common denominator. So if you start counting by 3s and 4s, the very first number you got that they would have in common would be 12. So we're going to take every single number in here. Sometimes, they call it least common denominator, would be 12. But in this case, what we're going to do is not least common denominator, we're just doing like a common multiple. Still using our denominators, but we're trying to find the first common multiple that they would have there. And then we're just going to take every single number and multiply it by 12. Sometimes they would call that the least common multiple, which basically is still the same thing as doing like your least common denominator. I mean, whether you want to say that or not. But again, instead of rewriting everything with a common denominator of 12, we're going to take what would be our least common denominator and multiply it by 12. And that way, 4 going to 12 3 times. Now we've got 3 times 3 for 9x. 3 will go into 12 4 times. 4 times 1 is 4y. And then 1 times 12 is 12. Now, I would grant that just about 100% of the people would say, yeah, I would rather work with this equation than I would with that equation. They're the same equations, just one of them has fractions and one of them doesn't. Okay. So, and again, you can do that pretty much anytime you want to. There's very few times where I would say if we're doing something not to get rid of the fractions if you feel like it. So just realize you can do that pretty much anytime you want to. Number 6 is actually a little bit easier because you only have one denominator. So we're going to take every single number in there and multiply it by 6. Okay, so the 1/6 and 6 would cancel, which would just leave you with x equals, and we're going to have 6y minus 12. And then again, we've got to get all the y's and x's together, so we're going to move that 6y over here. So we're going to subtract the 6y and move it to the left-hand side. Okay, now, and a lot of times they're not going to have you do a whole lot with standard form. I think the biggest thing really in that case is just being comfortable moving terms and moving different variables around just so that you have it so it looks like a certain different way. Because a lot of times they'll give you an equation, they may give it to you like this, and they may ask you to solve it in terms of x or solve it in terms of y, or they may have you just rearrange it. So the biggest thing is just being comfortable, not necessarily finding x equals something. But a lot of times we've got to rework it so that we're not just finding x, that maybe we're finding y, or just moving some terms around. So it's just, again, just being comfortable with terms and being able to move them around a little bit. Okay, slope-intercept form. All right, here's the one that everybody remembers. This is what we do when we're graphing everything. Okay, so that's your y equals mx plus b. And again, hopefully, maybe one of these days, 30 years down the road, you may have kids that are doing something. You may be saying, well, back in my day, we didn't, this is the only way we had it. One thing, that, again, that people are kind of moving towards too, maybe slowly but surely, we're getting to b plus mx. Because, again, to me, that makes a little bit more sense because you're going to begin with this number and you're going to move this number, and it just makes it flow a little bit better. But, again, anything book-wise we do, on MathXL, anything else, they're always going to come back to this one. Hopefully, maybe one day we'll be able to transition to that because to me that just makes more sense. So, okay, and m is the slope, and b is the y-intercept. Okay, and again, I think we mentioned this the other day, but we'll make sure we do it again. That when they talk about m is your movement to the next point. So when they talk about, why is slope M, why is slope not S? Because, slope starts with S. Well, again, it probably goes back that it was not an American thing to start with. So M probably came from whatever it was, the original interpretation was. But so in my mind, I just think, okay, M is how much your movement. It's how much you move to the next point. It's your up 3 and over 5 or down 4 and over 6, whatever you're going to do. And the B is the y-intercept. That's where you begin. So that's where you begin on the y-axis as you're going through that one. So begin here and then move this. So that's why to me this one makes more sense because you begin with this number and then you move this number, and that way they're in the order that they should be in. Again, I think that's going to be a slow transition to get there, but I think eventually, one day we'll do that. Okay, and for slope, if you remember from, I think we did this yesterday, didn't we? When we were talking about some slopes and different things with it, or maybe not, maybe we were doing something else with it. For slope, it says there are basically we have 4 types of slope. Okay, so when we're talking about slope, it's y2 minus y1 over x2 minus x1. And remember that in that case, that's what they call that always rise over run. I think everybody remembers that. But that's your up and down movement. Your run is your side to side movement. Right. And if you have a positive slope, then basically we're basically going to worry about the right and left ends on this one. If you have a positive slope, then the right end is up. Doesn't matter how you want to say it, what you want to do with it. If something has a positive slope, we're going to look at the ends of it. And there's going to be actually a time when we start talking about quadratic equations and graphing those. And same thing, we're only going to worry about the endpoints. We'll talk about what happens in the middle. So this would be one of those cases where the right end is up and your left end is down. Not so much worried about the left end in this case, but again, right end's up, left end would be down. Okay, if it's negative, it's just the opposite. Now your right end is down. And then the left side would be up. Okay, now here's where again I go back to back in y'all's shoes when I remember doing this one. Because you have a zero slope and you have either what they call undefined or no slope. And again, this is one of those things that I remember sitting in Algebra 2 going over this and kind of sort of got it good enough to go through the test. But if you had asked me probably one day later after the test, I couldn't have told you anything because it was just, I remembered it and it was gone. So when I started teaching it, I couldn't, that had to change because it wasn't one of those things that I could just teach it and then, the next day not remember what I was doing. So I had to kind of memorize some way of doing this to help it stick in my head as we're going through this one. So we know we've got positive, we know we've got negative. When it comes to our next 2 lines, either we're going to have a horizontal line, or you're going to have a vertical line. And one of these 2 was it. And again, I memorized it just long enough to get through the test, and I forgot about it after that. Here's the way I actually have it now, so it's stuck in my head, and I won't ever forget it on this part of it. You've got vertical and horizontal, right? I'm just going to write this on a separate piece of paper. And it seems funny that you use words in math to make it make sense, but I actually use words in math to make this one make sense. Okay, so it's got to be one of these 2. So it's either 0 and vertical or 0 and horizontal, or it's got to be one or the other if we go through this one. What finally dawned on me one day was 0 has a Z, horizontal also has a z. There we go. So those two go together. And it seems like it's something as simple and as goofy as that. But when I saw that one day, I was like, oh, wait, you don't see a lot of Z's. Now you see it in math because it's zero all the time. But I made the connection. I was like, wait, zero has a horizontal, has a Z also. They both have a Z. So if something is a zero slope line, it's going to be a horizontal line. And I was like, okay, if I can memorize that one, as long as I know this one, I just know that the other one is the other answer. So I didn't even worry about memorizing that one. So if I know that zero is horizontal on a line that goes through it, then undefined has to be a vertical line. And I just kind of made that connection one day, and I was like, okay, there we go. That's the one little thing I need, so that I'm not just memorizing it for the test and whoosh, it's gone after the test. This one I can actually kind of make it stick as we're going through this thing. So if you have a horizontal line, the slope is going to be zero because it doesn't change any up or down. It stays the same. And if it's undefined, that's going to be a vertical line. And again, sometimes they call it vertical line. Sometimes they call it no slope. Usually, now if it's Math Excel, they'll give you a option that's either they'll give you an option that says either no slope or undefined. I forget which one it is. That one, it's just a button that you'll click on, so you don't have to worry about it. And I'll take answer either one if we're going through a test and doing so. Okay, so there's your basics. There's where we're going back and just making sure that, again, this is how we're going to graph these, and this is your basic things for this one. And again, we don't necessarily graph these later on, but there's going to be a lot of graphs that we're going to use where we're going to use vertical and horizontal lines to help us get through some stuff as we go through that. Okay, and then on the back side. All right, here's where we get a little bit of practice just to make sure everybody remembers how to graph lines and how to do all the stuff that's here. So in this case, with y equals 2/5 x plus 7, there's your slope. It's 2/5. Your b value is positive 7. And actually for this one, make that a negative 7. Just to make this one a little bit easier. We'll come back and talk about the other part of it here in a little bit. Okay, so we're going to start at negative 7. It's not the very, very, very bottom, but we're just one up from that bottom spot there. And your slope is 2/5, so from this point, you're going to move up 2 and then over 1, 2, 3, 4, 5. There we go, and there's our 2 points. All right, again, as long as your slope is positive, the right side should always be pointed up. And again, depending on the b value where it is, that's where we're going to go. Okay, now let me do this one just to kind of show you what it is. If that had been positive 7, if that had been positive 7, it was here. So in this point, if you go up 2 and over 5, you're off the graph, right? You're up here somewhere. So if you can't go up 2 and over 5, what's the other option to kind of do? Yeah, do everything backwards, right? So instead of going up 2 and 5 right, do the opposite. Go down 2 and then 1, 2, 3, 4, 5 left. And that way, if you do draw the point, then if you connected it, it would connect with that point that's up here. Okay, so just one thing that does come in there, again, every now and again, where we're doing some graphs on Math Excel, you'll have one that will be off the graph. So again, if you get one, if you do up 2 over 5 and it's up off the graph, just do both of those things backwards. Go down 2 and then back 5. Because if you count it from here, you would go up 2 and over 5 to get there. So that's one thing you can always kind of do if you need to. All right, now number 8, it's got f of x. And just remember, and we'll actually talk about that pretty soon, that's still basically just your y equals for that part. This one's already set up, so your m is -1. Your b is at 2. And again, for slope, it always needs to be rise over run. If it's not a fraction, it's always going to be over 1. So begin at positive 2, go down 1, over 1, and then it's the next point there. And that one's really close. If you want to do it again, just to make sure you get your line nice and straight, you can always do that. Okay, but number 9. Now here's where again we're kind of going back to the last problem and doing a lot of stuff. In this case, you've got to get it so that you can do. Now you could do intercepts in this case, but again, if you try to do x and y intercepts like we're doing today, if we cover up the y value, this x is going to be at negative 15, and you're off the graph. So this would be one where they wouldn't have you do x and y intercepts just because it's off the graph. So in this case, they want you to go back and rewrite it in y equals mx plus b form. So first thing is, let's get rid of the x. So we got 3y equals negative x minus 15, and then just divide everything by 3. Okay, so that gives us y equals negative x over 3 minus 5. And again, if you think about that as being a 1 there, we've got our slope now is negative 1/3, and our b value is at negative 5. So we're going to begin at negative 5, which will put us there. And if we go down 1 over 1, 2, 3, should put us about there. Wait. Yeah. Okay, and then number 10, last one again. We still got to get the y by itself. So for this one, two things. We got to get rid of the 4x. And we also need to get rid of the 1 to keep the y by itself. So let's go ahead and do both of them at the same time. Because that'll get rid of the 4x. That gets rid of the 1. So now we've got y would equal negative 4x plus 1. Okay, and again, for your slope, it always needs to be over 1. So if it's not a fraction, just put it over 1. So we'll begin at positive 1. And then we're going to go down 1, 2, 3, 4 over 1. Okay, and again, if we're doing slope, as long as you can get it on the graph, you always move to the right-hand side just because that's just the rules. That's the way somebody made it, and that's just kind of the way we go with it. So, okay, now here's the fun ones. We got vertical and horizontal lines. It says write an equation to represent the line showing this one. Okay, so now if we kind of flash back to what we had on the backside. If it's a horizontal line, what's the slope going to be? Yeah, slope equals 0, right? So, okay, that's a horizontal line. So if we're going through number 12 here, that's the horizontal line. We know that the slope is going to be 0. All right. If it's a vertical line, then we know that this slope is going to be undefined or no slope or whatever they want to do for this one. Okay. Now, and here's where I used to struggle with this one a little bit. And again, I'm going to kind of give you some insight on how we get to this one. And I'm not going to tell you the wrong way to do this one because sometimes you do something the wrong way and then you wind up doing that. Vertical and horizontal lines. There's no, left side up, right side down kind of thing on this one. It's either everything's one direction. It's either vertical or it's horizontal. So when you get to these two, you only going to use one letter. So if it only goes one direction, either vertical or horizontal, because there's no tilt to it, you only get to use one letter. And the letter you use is the letter that it hits on with the axis. So this vertical line hits the x-axis. So you just tell me where it hits that axis. It hits the x-axis at -3. If it's a horizontal line, it hits the y-axis at 1. So just tell me it's y equals 1. Okay, now, and again, if you kind of get to the point where you're going through this one, and let's say you get later on and you're like, okay, that for some reason you miss out on this one. Here's the other thing you can do. Go back and if they give you a line like this, go back and plot this line and tell me what like 2 or 3 points are. So if I go back and find the points, this point would be at -3, 0. This point would be at -3, 1. This point would be at -3, 2. And if you plot the points, you'll see what they all have in common. All these points on this line, they always have -3 for the x value. So you just tell me x is -3. Same thing if you plot everything here. Every single point here is going to be at, so if you plot a point back here or over here somewhere, this point's at like -5, 1. This point's at 0, 1. This point's at 6, 1. That every single one of these points, if you plot it, the y value is always 1. So it's just going to be y equals 1. Okay, so again, it's just, and again, sometimes if you get stuck on these, just go back and do the basic simple things. Just write down some points of what's on the line, and then again, you'll see, oh, okay, it's always got x equals -3, so that's x equals -3. Every single one of these points on the line always has the y value at 1, so it's just y equals 1. And whether they ask for this thing in slope intercept or standard form or point slope or whatever, that this is the equation no matter what you do, whatever form it is, because that's always going to be the exact same thing. So whether that's point slope or slope intercept or general form or standard form or whatever, it's just that equation, that's it, and that's all you do. Okay, and then the last thing we'll look at, and again, we'll just do just a little bit with these. Parallel and perpendicular lines. Okay, we know what parallel lines are, right? They never touch. Okay, that's usually what people say. But mathematically, what do parallel lines have that are the same? There we go, slope, right? So slopes of parallel lines are, we'll just say equal. So we would like to say it's the same. That's fine. So if we can figure out that if we do two equations, rewrite them in y equals mx plus b form, and the slopes are equal, the slopes are the same, we know those lines have to be parallel. Okay, and if you have perpendicular lines, and I always like to say this one a little bit different because the way the book says it, we get it, but sometimes it makes this one. If you think about perpendicular lines, they make an X or a T. One of them's going to be positive, one of them's going to be negative. So we're just going to say that in this case, that these perpendicular lines, they're opposite sign reciprocals. Because again, we know one of them's going to be positive, one of them's going to be negative. And then basically, if let's say the positive slope, let's say if we're doing this positive line, if that slope was 2/3, the other one is going to be the opposite, and then we're going to take the reciprocal of it. So it's going to be -3/2. So if you know what one slope is, to find the other one that's perpendicular to it, again, you flip it, you do the reciprocal of it, and you change it from positive to negative. Because again, anytime we're doing any kind of line like that, whether it's tilted like this, or if it's like that, doesn't matter what it's going to be, that no matter how you turn this thing, there's always one that's going to be positive and one that's always going to be negative, no matter how you tilt this thing as you go through this part. Okay, so what we're going to do, we're actually going to go and just do a couple of these. Let's do 15 and 16 here together. Just make sure we got it. All right, so with 15, it says determine whether the lines are parallel, perpendicular, or neither. So for 15, let's just get this thing in y equals mx plus b form. That is a -8x there. So let's add 8x to both sides. So we got 8y equals 8x, or if we divide both sides by 8, that's y equals x. But again, if we're trying to figure out, parallel or perpendicular, whatever we're doing, we just need to know that in this case the slope is 1. Okay, for this equation, we're going to solve it for y. So for this one, we're going to subtract the x. So negative y would equal negative x plus 4. We're going to change this to a positive y. So we change this sign, we're going to change this sign, and we're going to change that sign. So slope also equals 1. So again, they have the same slope, so that means those lines have to be parallel. All right, and 16, kind of a little bit of a trick question because it's got x equals 2 and y equals 2. So we know that this one's going to be a vertical line. Y equals 2 is going to be a horizontal line. So this one's vertical, this one's horizontal. Does that make an x or a t? Yeah, it does, right? So in that case, that still would be that the lines are going to be perpendicular. Because again, we know that one of them's going to be horizontal, one of them's going to be vertical. So if they're horizontal and vertical, then they're going to make a perfect x, or again, in this case, the way it's turned, it's going to be more like a perfect t in that case. All right, now, and if you do this one, just kind of give you an image on this one real quick. And that's one you don't even have to show any work. You just go, oh, yeah, because this one's got no slope, this one's got a slope of 0. But if you were to graph this one, we've got one line at x equals 2, so there's our vertical line. We've got another one at y equals 2. There's our horizontal line. So in that case, if they ask you, what's the solution where these two lines graph or meet when we're going through this one, the x value is 2, the y value is 2, so 2, 2 would be your point of intersection. Or, if we start talking about some stuff later on, this would actually be like the solution. If they said, find the solution for these two equations, you're looking for where the two equations would cross, so that would put you there at the point 2, 2.